Hi guys, and welcome to the soils engineering video. We're going to talk, as I mentioned, just a little bit about soils right now. And let's turn around so you can kind of see what we're talking about. I'm out here in a farmer's field in my neighborhood, and you can see what you'll see right here is that, we've got some orangish colored soil, and in the background over there you'll see that there's some much darker looking soil. And what makes that interesting is that those different colors means that the soils are made from different things, so they have probably some different properties. So let's take a look at the soil right here at my feet for just a second. You can see here, you can see that you can see some cracking right here and some kind of speckled colors, and that's part of the minerals that are in the soil. And let's take a look. So this looks pretty dry here on the surface. Now let's dig down a little bit. You can see that dry area is very much on the surface of the ground right here. And as you get further down, the soil is much more moist and moist. And you can see that at the top you have some pretty big kind of clods that are holding together. And down here in the bottom, those clods are easy to break up, and that's because of the different moisture contents. This here is a very dry surface soil, causing these clods to form, and down here below you'll have softer, more clay-like soil. So you can see you can make a ball out of this, and that's really because of the moisture content of the soil itself. And the thing that makes clay soil kind of cool is that the property of the soil itself is really, it really changes with how much moisture is in the soil. And we're going to take some of this soil back into the lab and show you guys a little bit more about that. Thanks. Okay, hi again kids. Now we've brought our soil sample back from the farmer's field, and now we find ourselves here in the soils lab here at the Corps of Engineers at Camp Humphreys. So you can see, take a look around. You'll see a lot of different equipment in here that we use to test the soils. So what we are going to do right now is that we've got our soil sample, and now we're going to show you how to take that soil and separate out the particles of all different sizes, starting using these sieves right here that you can see. So you can see the first sieve is a number 4, and it has relatively large holes in it. So it's going to trap the very big particles on the top, and then the finer sands and clays type soils are going to move through the sieves as we go. So now the screen is a little bit smaller here. Quite a bit smaller here. And finally some very, very fine sieves. And the remaining soil that goes through all the sieves will wind up here in the pan at the end. And let's take a look at our soil sample. You can see it's got a wide range of particle sizes here, so we should be trapping some of these sands and gravels and soil on each of the different sieves as we go. So are you ready? Here we go. Okay guys, here we go. We're just going to add the soil. You can see our sieves have been stacked with the very big mesh on the top all the way down to the very fine on the bottom. We'll add our soil. And this is where we start to shake. Okay, let's see how we've done here. Oh, very nice. You can see on our top screen, there's a lot of the gravel sizes right here. Going down to the next level, we've got a bunch of sand here on the next screen. We've moved some of our sand down a little bit further so that you can see it's a little bit finer grain material now. Now we're getting down into some very fine sand. Now, very, very fine sand. And finally, some silt and clay size particles at the bottom in the pan. Now that we've actually shaken our sieves and separated all the different soils to, of different sizes, now we put them on the scale and weigh each portion.
Yeah.
We're starting with the gravel.
The gravel. Yeah, right.
Okay. How about the next one? $78.
About 200 grams.
Yeah, 206 grams.
Yeah. Oh, 99 grams.
99 grams.
Yeah,
16 grams. And finally, on the pan at the bottom, just a little bit.
Yeah.
2 grams. Now it's time for our homework assignment, kids. This is what we want you to do at home. We want you to get a glass jar or a large cup from home. And what we're going to do here is that we can separate the soil by particle sizes by putting the soil in water, and the heavier particles are going to go right to the bottom, the large particles. And the smaller silt and clay sized particles are going to float around a little bit and slowly settle to the bottom. So let's do an example of that right now. You can see some of the particles went down right away, and it slowly the finer particles are starting to settle out as well. We don't have a long time to wait for this to happen, but you can see here in the bottom that there are some of the larger particles are already beginning to collect here at the bottom, and you can see right here where the fine silts and clays are still continuing to settle out as well. So this is what we want you to do at home, kids. Get yourself a good-sized jar and some soil from your neighborhood and fill that with water, and go ahead and put your soil in there and shake it up really hard, and then watch those particles really settle out. And tell us what you think of that in your video that you guys make for us. Okay? Go for it. Okay, so now, kids, this kind of brings us to our summary and why is soils engineering and geotechnical stuff important. So let's take a look. We've got our building right here. And underneath our building, we've got our foundation soils. And down here at the bottom, we've got bedrock. So here we've got some really hard sandy soil, and then below that we've got some hard clayey soil. And what we're trying to do is prevent settlements for our building that are going to cause problems for our building. So if we've got very hard soils here, we might just be able to put just a very shallow foundation for our building right here. And that's cheap and easy to do. Now, but if we come over here to our second building, we've got very soft clayey soils at the surface and more hard soil, sandy soil down below. So in this case, we may have to drill down and put much deeper foundations over here so that we can get the weight of our building down onto the hard sands below. And obviously, this type of a foundation for our building is going to be much more expensive and costly and time-consuming to build. So that's really what makes soils engineering important. We want to go out there, find out what kind of soils are going to support our building, and adapt our design to accommodate those. Okay, kids, thanks a lot. Enjoy. Now go out and do your little experiment. Bye.